This particular lesson focuses on a worksheet, and so I just want to demonstrate that a little bit for you. I'll just do a few examples, but it's going to ask you to dilate using a certain center, so in this case C, and a scale factor of 2. So let's make this a little bit bigger here and make this work. So if C is our center, which it is, and we're going to dilate everything by 2, you need rays, right? You need to extend those rays out. And you would need to extend this ray out. And then you dilate by 2. Now, a way to do that is to basically count out your rise and your run there. So I go 2 to the right and 1 up. So to go 2 times that, I would go 2 to the right and 1 up. And so I get this point right here would be my B prime. And then here, again, over on the left, I would go 1 left and 3 up, 1 left and 3 up. And I would plot that location up in this spot. And then I would do my best to connect these. This is the dilation of by 2 out of the center. Notice that this point didn't move, it was invariant. Notice that we get parallel lines here in that, and you're dilating by a center. Let's look at another example. Here we are, as it says in the upper left there, we are going to dilate this guy 2 times, and we're going to do it by H. So this time, the center is not on our object, and so you need rays. So again, let's create the ray centered through D. Center H through D, let's go this way, and let's go this way. Now once you've created your rays, you can then count out your doubling. So this distance here is 2, so I'd go 2 more up into this position. So D prime would be here. To dilate from H, the point E, we go down 1 over 2, down 1 over 2. My line's just slightly out. That happens when you're just drawing freehand on the iPad here. And then the other one, that would be, of course, E prime. And then the other one is down 1 over 1, down 1 over 1. So now I pull out my straight edge as best as I can. And I create the 3 lines that form that. And you get this really kind of interesting relationship here again. You see parallel lines appear here. You see the parallel lines appear here. You see the parallel lines that appear here. Very cool. Everybody is being expanded by 2 times, and it doubles the size of the object. In this case, again, we're going to dilate G using a scale factor of 2. Looks like I picked all the scale factors of 2. From G, notice G is not on our object. So let's get this nice and big so we can work with this. Again, it's our center. So let's draw the rays from G through each of our guys here as best as we can. And again, I apologize, I'm doing this kind of freehand a little bit. So let's expand that. So this guy is a distance of 2, it goes 2 more. This would be our guy here at A prime. Now this guy going down is 1, 2, 3, doubled would be 6. So this is our C prime down here. This next one, my line is a little out, so it'll make a bit of a mistake, but let's count the slope. That's always the way to do it. 1, 2, 3, down 2, 1, 2, 3, down 2. So it actually should be right in that corner there if I had drawn it better. And this would be our B prime. So let's play connect the dot. C prime to A prime would be this, and then here, and then here. And so if I pulled out a little bit of shading here, if I shade this guy in here quickly, this would be our solution. This guy right here would be our triangle that is 2 times bigger than the other. What I'm trying to show you by doing it with you again is this idea of slope And maybe just I'll emphasize it one more time here. To dilate the point B, I counted over 3 and down 2. And then I needed to, if I'm going to do it twice, I need to go over 3 and down 2. Slope is a major part of, again, that idea of dilation and moving up and down a ray. This next one I chose because it uses a unique scale factor, a negative scale factor. Now, some of the other ones you will use like -2 or something like that. But if you watch how I do this one, you'll be able to do any negative scale factor here. So let's bring this up. Now, negative. Well, first of all, let's draw in our rays to begin with. So there's a ray here through C, and there's a ray here through B, and then there's the ray through A. Now, the key to a negative one is that you will perform the motion out the opposite ray. So let's create the opposite ray here and the opposite ray here. And this one as 1, 2, 3, 4, up 1, 1, 2, 3, 4 here. So just to help me graph that, I wanted to plot a point. So do you see what I've done there? I have created the opposite direction. That's what negative will do. So let's start with the point C and do a dilation of -1. That just means go in the opposite direction, the same distance, and so on. So if this is 2 up and 2 over to get to here, then negative would be 2 down and 2 over to here. So our location would land here at C prime. Now to get to A, you'll notice I went 1, 2, 3, 4 and up 1. So going the other way would be 1, 2, 3, 4 and down 1. So our new point is right there, and this would be A prime, actually. Then we would need to do that with B. Now B was 1 down, 1 over, so going the other way would be 1 up, 1 over. B would be right here. B prime would be. So if I connect those dots here, here, and here, what I get is a dilation of -1, which basically just means, you can see it, it's a rotation of 180 degrees, isn't it? Now, if this was a -2 or something like that, you would just go in the opposite direction twice the distance that you went with the original one. But you can see this is basically it's in the opposite direction, and really a rotation is what the result is when you dilate by -1. The last page has you do the opposite, work backwards. In other words, the dilation has taken place, and they're going to ask you what was the center of that dilation and what was the scale factor. The key to that is to create the rays. So to basically, connect through there, create the ray through CC prime, create the ray through BB prime, create the ray through AA prime. Now, because this was a dilation, they will all find a center. Now, there is our center. They will always meet at a single location. Now, because I'm hand drawing this, it's just slightly out, but that obviously is our spot. At -2 and 1 would be this. The next thing I need to do is look very carefully at again, the scale factor. Now, I do see that CC prime is further away, so I know that the scale factor is going to be bigger than 1. And you might say, well, how do I know how far that is? I don't have it. Just count your slopes. Watch this little technique here, and I'll actually map it out for you. So this point here, C, is up to and over 1. To get to C prime, I go up to and over 1 again. Do you see how that is just 2 of the slopes, right? Once, twice. I could actually do that with another point. For instance, I noticed that this is 2, but this is 4 away. So 4 divided by 2 is this. I could check it with A as well. Let's do that. Again, in A's case, what I'm going to do is slow, or kind of a rise run thing. 1, 2, 3, 4, and up 1 to get there. 1, 2, 3, 4, and up 1 to get there. It took 2 of those slopes. And again, confirming that the scale factor is 2. Be careful, there's a couple where the C prime is closer to the center, and so it's a contraction instead of an enlargement.